Naturally, the population of the world is increasing, and with that increase, more problems come. A bigger population means the need of more production in everything, from toilet paper to houses, and the broiler industry is not the exception. Broilers have to grow today more than ever to cover the world chicken demand, which is why new means like the addition of enzymes to chicken feed have been introduced into the industry. Ronosine Proact is a heat-stable monocomponent protease that, when added to broiler diet, increases the digestibility of proteins and reduces production of substances like nitrogen, which is one of the major pollutants in the world. The enzyme market for cattle feed is growing. By 2020, the value of this market is expected to reach 1.371 million US dollars. This growth is indeed no coincidence. Benefits from using enzymes are big. For example, if a broiler grower grows a million chicken per year with an average weight of, let's say, 2 kilograms, and adds 1 kilogram per ton of ronosine proact to the feed, a 2.5 tons reduction of ammonia in manure is expected. That means that 18 acres in area of land required to dispose all that manure is saved. At the same time, this means that one can grow more than 70,000 more broilers without the need of new land and still save up to 3.7 tons in greenhouse emissions. Therefore, products like Ronosine Proact are just necessary for a healthy growth of this industry in this rapidly developed world. Now, now the importance of this product is understood. Let's talk about the production process of Ronosine Proact. The general production process is divided into three stages: upstream, process, and downstream. Upstream stage has to do with the research of the best microorganism to produce the product, the optimal condition to grow that microorganism, the optimal medium, and etc. The second stage is the fermentation itself. And the last stage, the downstream, has to do with the purification of the products. That means the filtration, concentration, purification, drying, and the final product. Each stage will be explained in detail next. The upstream process. The microorganism that Novozymes chose for the production of the protease is Nocardiopsis dasonivelli strain OPC 210. Nocardiopsis has many advantages, which is why it was chosen, of course. The protease produced in the microorganism is a primarily metabolite, meaning that the protein is secreted to the medium, therefore downstream process is much less expensive. The product is thermostable as well, which is a characteristic needed because the protein is meant to be working inside the small intestine of the chicken, which has a high temperature. Um, it has a high yield and a high activity as well, when medium suitable for protease production is added, as we can see in the graph 1. As we can see in this slide now, the best nitrogen source for protease activity is casein by far. 9.02 of protease activity against 2.31 with the coconut press cake. And talking about the carbon source, the starch at 1% is the best one, because if you compare it with the starch at 0.5%, that has an activity, a protease activity of 5.2 against 10.2. So that's a big difference in protease activity, which is why the starch and the casein were chosen as the best medium to induce the protease production. The potassium phosphate, a salt. Then we have glucose as a secondary carbon source, and sodium carboxide is added as well in the medium. Now, let's talk about the conditions: temperature, oxygen, pH, and the agitation are crucial for an optimal growth of the microorganism. The graphs shown in the slides demonstrate the best condition for growth. For temperature, 30 Celsius degree is the optimum one. 10 for the pH, and 200 revolutions per minute for agitation. Of course, our microorganism is aerobic, therefore oxygen is needed to be pumped. For the fermentation, a batch system with submerged fermentation is used. This is now the fermentation itself. So we just pass the upstream process. Now we are in the process itself, as you can see. The bioreactor is made of stainless steel. It has a capacity of 316 liters. It has a heating circuit to maintain optimum temperature. The agitation is made by blade stirrer baffles, and it has a submerged aeration and an auto sterilization. The bioreactor is loaded with an inoculum in order to have the minimum microorganisms numbers so it survive. First, a small inoculum is needed. Usually from 300 to 500 milliliters are loaded into a flask with medium. And after this inoculum is prepared, the same inoculum is loaded to a pre-fermenter. And last, it is loaded to the main bioreactor. So it goes from little media with little cells to medium cells and a little bit more medium, and then from that it goes to the big bioreactor, which is the main one. That's how you assure that your cells will survive actually in the big bioreactor. And now let's change to the downstream process. For the downstream process, centrifugation is done. The centrifugation is done at 10,000 revolutions per minute and at a pH of 5. This is to remove the cells and recover the supernatant. Our centrifuge is not a normal one. Is a decanter centrifuge is the one that is chosen, because This centrifuge can achieve quite good degrees of clarification of the liquid concentrate, and that's what we want. Um, we want this centrifugation can handle big amounts of solid separations as well. The principle of this decanter centrifuge is based on the differential speed between the screw and the scroll. This provides a conveying motion to collect and remove the solids which accumulate in the ball wall. So here we are taking advantages of our extracellular product, and we just remove the cells from the medium, and in the medium we have our protease, which is going to be our final product. Next, the concentration of the enzyme has to be done. This concentration is achieved by an ammonium sulfate precipitation. As seen in the slide, the precipitation is achieved at 80% saturation by adding powdered ammonium sulfate slowly with continuous shaking. This process is called salt in and salt out, and it relies on the solubility of salt and the interaction between the salts and the proteins. As we can see in the graph 5, ammonium sulfate attaches to the proteins, and when the saturation is achieved, the protein precipitate. Also, ammonium sulfate is chosen because it is the most effective precipitator, as it's proved in graph 6. Now, once the product is concentrated, it must be dried. A contracurrent spread dryer is used for this. The concentrated solution is fed into a sprayer and released in small drops. Air at 80 Celsius degree is pumped in opposite direction to the drops, and so the drops dry up. The dry product goes into a cyclone separator, and remaining gas is taken out from the product. This stage, the powder is ready to be packed and distributed. And with this is how we conclude the Robozymes ProAct bioprocess. Thank you.